Peter, how you doing?
We've got 10 years to decarbonise all of the industries to stay under 1.5 degrees. What we've got to move away from is seeing carbon as being a product that we can take out of the ground. We have got so much of it in the atmosphere. We need to be taking it out of the atmosphere, putting it into products, and these products need to be storing the carbon for a long time. So this is why I'm so excited about building products. Building products, we can stick it into wall panels, we can stick it into carpet, we can stick it into all these different structures that keep the atmospheric CO2 out of the atmosphere for decades. That's what the future is. And we don't have to compete with forests and other ways that we're going to be storing carbon. We need this on top of forestry, not in place.
So hopefully we won't have to worry about the optical problems here, but these will start transforming things with us. So it's good that we've been able to secure the hotel.
The importance of automation in these scientific discoveries is really twofold. One, it's to minimize the costs of operations, and two, it's in order to have the level of accuracy which humans are normally prone to having when it comes to repetitive exercises. What this robot here does behind us is it does the work of 20 scientists in a single year. It enables us to accelerate discovery, it enables us to reduce the costs of operations, and most importantly, it shifts the scientist's focus from doing low-level type work to high-level creative scientific work. It helps the scientists do what they need to do, but it also reduces their footprint in terms of carbon emissions. And in turn, they are discovering algae, which are going to also reduce the carbon footprint of the institution, but also the world. Each station has its particular role. Some of these stations, as you see in the middle, which we call the hotel, the name itself describes the place where the algae live and the algae grow, and the algae actually are provided with all the conditions that they need to multiply. What happens then is that the robotic arm, much like the human would previously, accesses that hotel, pulls out a particular sample of algae, and then moves them to different stations for analysis. We have different imaging technologies which allow the system to see things that human eyes cannot see. It allows us to then capture that data and push it through various software packages, and the software packages allow the scientists to do in-depth analysis, comparison studies, etc., ultimately helping us accelerate the discovery process to find what we call the super algae.
Algae react light. Yeah. Just in this.
This is an absolute game changer because this is going to speed up the process by which we can transform those industries. If every single industry takes 6 months to find the elite strain, we're going to be here forever coming up with these solutions. The robot will speed it up. We've got 300,000 species to choose from. We've got to start picking the winners very quickly. Industry knows what their compounds are. We've just got to find it in the algae and then transform that really quickly so that we're at market and we can start with, within this decade to have the industries transformed. The goal that we have here is to transform all industries so that they become sustainable and they become carbon negative. So we use carbon from the atmosphere to make products for society, and we stop using fossil carbon to make those same products. So Algae can replace plastics, construction materials, pharmaceuticals, food for humans, food for animals. All of these things, we can transform all those industries by finding the right algae that makes the right compound so that we can change the industries. So essentially what we have to do is once we've found the algae, we find the elite strain, we work out its environmental conditions to grow, we grow it en masse, we do some form of green chemistry extraction to take out the products that we need, and then we transform those products into plastics, let's say. But one of the really important things to do is make sure we've got zero waste. So some of the algae will turn into the bioplastic, some of the algae will be a product that we have to turn into something else. So that could go into feed, that could go into biochar, but we have to use all of the biomass and not waste it.
And once the commercial processes adapt what we're discovering here, that's when we'll truly start to see the scalability on the impact of these particular scientists' work.
Start by not moving it first.